Hello there, thanks, and welcome back to this, the Developer's Guide to Windows 10 Build 10.2.40 update. We just in the last session we did Xbind, and we got a couple of questions. You want to take them?
So we've got a couple here. So it says, can compile bindings be used with generic types? Answer is yes.
Yeah, I mean it's just a type, isn't it?
Yeah,
if it can compile, we can kind of bind to it.
Yeah. I think we've got another question. How does data binding in XAML behave when using .NET Native? As we know, .NET Native doesn't rely on JIT compiler, which is normally used by reflection.
That's a good question.
Good question.
Yeah.
So .NET Native, it sort of still has a way of doing reflection. It's like a special sort of area of .NET Native that can handle this sort of stuff, right?
Yes, yeah. So I mean, it's all with the idea with .NET Native is to do away with the JIT compilation and and reflection and all that sort of thing. But yeah, so it actually kind of drills down and there's some magic happens.
There is some magic, but
there is the kind of this little reflection engine that will handle these kind of instances. Yeah.
Yeah.
So okay, hopefully that answered that.
Yeah.
And we're going to talk a bit more about .NET Native in the store session this afternoon.
Yes.
Yeah.
Very briefly.
Big perf improvements from that.
Yes.
Anyway, this session we're going to just talk about, just a short one, we're going to cover background execution, background tasks. I mean, it's a short one now, it's a big topic, but it actually kind of, this is the introduction because it turns up again in tiles and turns up again in Cortana, speech command processing. In fact, we're going to keep on creating background tasks really from the rest of the day. So this is kind of the introduction to this topic. So this is the idea that, we spent a lot of time yesterday talking about the app lifecycle, and that was really focused on how the foreground app works and what you have to do as a developer to handle termination and suspend and resume and all that kind of stuff. So that's the foreground app.
Yeah.
Now, we can also actually run some stuff in the background, so non-UI, and it's just run. The system will run it on a schedule, or you can have some trigger that causes it to run, and you can do interesting things to draw users into your app. So this is a beautiful thing. How do these tiles update? Well, there's two ways they can update. They could update directly from the cloud, from your cloud services, or you could actually have a background task that's running and updating them. So, giving fresh, relevant content to users. This is what draws them into using your app. And you can delight them with features. Marketing person wrote this. Yeah, but this is what it's about. It's about the tiles are a great feature, and that's one thing. Toast notifications. It could be doing some data processing. There's loads of things.
There's a whole load of things, and based on various triggers, even like things like GPS and location stuff. Yeah,
that's right. Yeah, that's right. So what it's about is allowing your app to run logic when it's not running in front of the user. Yeah. So of course, it's a good thing. So. Things about building a background task. So first of all, what to say about it is when you add a background task to your project, what you do is you add a WinRT component project to your solution, and so it compiles into this separate little library, and then inside that you have a single method called run, which is the logic for your background task. But inside that run, there's a few things that you need to do, and a lot of people kind of miss these things because the simple hello worlds that we tend to build.
We never cover this.
Never covers this sort of stuff. So this is good practice coming out of. First of all, you need to find out at the time you run what's the current background work cost value. So you're asking the system essentially, how busy are you? And if it comes back and says, actually, I'm pretty high at the moment, if your task isn't, super necessary, you might be able to defer some of it. And then you really, in the interests of your end users, you should be a good citizen and maybe not do very much at that time.
Yes.
I can't imagine anybody, developer, really doing this, to be honest. But, actually, apart from our good selves, making sure our systems run as well as they can.
Well, users are the first people that will say, I've got this app and I've downloaded it, and now it seems to be like making my phone really slow when it's not running. They'll just uninstall it.
This is it. You know what happens to get on a Twitter storm if everybody suddenly says, "Oh, this new app sucks. It kills my machine."
Yeah.
So,
you don't want to be there.
No. You need to handle cancellation. Tasks can be cancelled by the app or by operating system heuristics.
So these are the termination we were talking about, wasn't it, before?
Yeah, that's right. So the system could cancel your background task. Maybe the user's configured. You've just gone into quiet hours or something. So basically quiet hours, your system quietens down, shuts down, and doesn't interrupt you anymore, and it won't run any background tasks. So you might be cancelled, or maybe the system's getting really memory stressed, and it's kind of trying to conserve resources. So there's various things why it might cancel your background task. You need to run in deferral most of the time. These days, calling async methods is just it's a
part of building an app.
It is what you do. So you need to run in a deferral. And you might want to progress feedback. So feedback is you can just fire this event sort of saying, I'm 10% done, I'm 20% done, maybe, if it makes sense for your app. And if your foreground app happens to be running at the time, it can receive these events, and you could actually have something on the UI to show what, the status of what's going on in the background.
Update in progress or something like that. Yeah.
So this is taking each of them in a bit more detail. This is how you query cost.
Okay.
So if you can't ask the system what's the current background work cost, and if the cost comes back as high, then you might want to maybe not do anything this time.
Not much code, but it's a big benefit. Yeah.
Yeah. So that's important. So that's what you're looking for. Obviously, if the work cost value is, I don't know what the other ones are. Not high. Presumably low would be one of them.
Low would be one of them.
Medium might be one. I don't know. We'll find out. This one is something that people don't do, and you really ought to do. Cancellation. So there's a couple of bits of this. So first of all, you see you get this is the run method. Every background task starts with a run method. This is your background task. Here the logic of it, and you get passed in this iBackground task instance object, and on that there's an event called cancelled. So if the system cancels you, that cancelled event will fire, and this is your chance at this point to actually to sort of shut down in a controlled manner. Looking at the logic here, it's actually quite difficult to follow. So task instance.cancelled plus equals SE means this is an event handler for what the system has just asked you to cancel. And what you do first of all is you cancel the cancel and dispose of the cancel. But what actually you do is that cancel thing is this cancellation token source.
So it's part of the tasks, right? So in essence, I suppose it's a way of cancelling an existing workflow or an existing task that's going on. And I suppose this is, from what I can tell, this is just making sure that if a background task then comes back up to life, you don't end up having something come in at the very last minute, so you're cancelling off the request too. And
what you're actually doing with this one is, these three lines here actually are the logic of your background task. And what you're doing is opening up a stream socket, and you're doing a asynchronous connect async over HTTP to server.com.
Yep.
And then this is where the magic comes in. The .asTask cancel.token is the cancellation token. So what happens in that task instance .cancelled? So first of all, remember that is fired in response to the OS saying cancel.
Cancel.
And then what you do is you call cancel on your cancellation token source,
which in
return will cancel that connect async.
Yeah.
So this is kind of it's complicated flow, but that's kind of how that works. And any async code needs to be wrapped in a get deferral.
Yes.
So there's the cancelled. So the cancel ties up with there. You're cancelling the cancellation token source, which is passed through.
This is really important for people to know, really, because sometimes if you forget it,
that's right.
It can be a bit disastrous.
We're talking about the deferral, running in a deferral. Any async stuff you need to do, make sure you get a deferral at the beginning. If you don't do this and just run through this, as soon as you hit that awake, your run method will actually kind of return, and effectively your task will just fail. So you need to get a deferral, do all your async work. There's an await task.run async, await task.delay, which is not very real world, but it gives you an example. And then when you're done, you can call complete on your deferral.
Yeah.
That's what you're doing.
It's just basically saying, I want to do some work, and then I'm done.
Yeah, that's right. Here's an important thing as well. An app can have more than one background task. A lot of people don't realise this. You think you can only have one, and it has to be this all singing, all dancing thing. Now, we're moving now to how you actually kind of register. This is a foreground app, is what it's doing now in order to get this task to run. So, first of all, your foreground app has to request access async. Now, there used to be this thing with background tasks. You had to be on the lock screen in Windows 8.1. This was a cause of great pain to people. Because not all the apps that run background want to be on the lock screen. Didn't make a lot of sense. Anyway, you still have to ask for access, but you don't have to be on the lock screen anymore. So it's basically, you're probably going to be, you've got to check the status that comes back from that. If you get back one of these allowed ones, and there's two flavors, may use active real-time connectivity with always-on real-time connectivity. There's edge cases and when you might want to do something slightly different for them, but essentially those two mean you're good. Denied means no, you can't run in the background. It's because things like the user they have like they can look in settings. They can find out which apps are enabled for background tasks, and they can
explicitly
disable it.
turn
Say,
it
I
off.
really don't want this one running in the background. So you might get denied. Unspecified means unspecified. I don't know. Will you ever get that one? But essentially, it's denied or allowed. So then, if you get an allowed one, then you can carry on. So you're requesting the access. And then, if you get allowed, then you can do this. You need to create yourself a background task builder object.
Yeah.
And inside that, you set some various properties on it. So the name is the name of my background task. You actually give the name has to be the actual namespace, the full namespace dot class name of your background task. Various other task entry point is again the type of my background task to string in this case. And then you can also do some other stuff which we're going to talk about, set triggers and add conditions. But the important one is to call task.register.
Register.
That's the thing that actually then registers your background task with the system. Now, there are a whole bunch of triggers on 8.1. These red ones there were the Windows 8.1 ones.
Yeah.
Not that many. 6 of them. System trigger, time trigger, maintenance trigger, device use, device servicing, push notification trigger. These are all different causes for system triggers, things like time zone change and network gone. Time triggers on a schedule. Maintenance trigger is something for doing long running sort of updating of connected things. Device use, device servicing of those. Push notifications are a really interesting one. Got a push notification that comes in from the cloud, triggers your background task to run, a raw notification. So that's really good. Then in addition, Phone 8.1 had some extra ones. Cached file, so it had those and these. Cached file updater. Device connection change, that's all Bluetooth and device connection change and GATT characteristic of these things with Bluetooth profile. Devices coming and going. RFCOM, another one like that.
Very similar.
And then location trigger is about geofencing.
Yeah.
This is all the bunch we've got on Windows 10, a whole bunch more. So we've got Bluetooth LE, that's Bluetooth beacons.
That's a low energy stuff, yeah.
Yep. Not sure, ones at the top, not sure what they are to be honest. Things to do with appointments, contacts, those are probably specialised ones, not for general use. But then device watch, activity sensor, sensor data threshold, toast notification, history change. I'm going to talk about them in the next session. Of all of these, I'm going to pick up on one in particular. This application trigger is an interesting one.
Yep.
This is a way for a foreground task to actually cause its background task to run on demand.
Oh, right. So
couldn't do that before.
So, you know, before we used to have like these periods of like either 15 minutes or 30 minutes. Is that sort of a on request or?
I'm going to come on to the quotas in a little while. Actually, yes, I'll come on to that. So, it's a good story with quotas, so it gets refreshed, renewed every so often. But we'll talk about that in just a while. All right, let's just have a look at a very quick example. Keep it very simple at this stage. I've got a very simple app here. It's got a background task. And incidentally, if I was going to add a new background task to this, you can do add new item. And the type of one you would want.
Oh, it's new project or item?
I meant add new project. That's what I meant. Sorry, thank you. Add a new project. The type of one you want is a Windows runtime component, one of those guys. This is where you could get. And then we've already done that in here. Here's our background task. We've actually got 2 different background tasks in this project. Let's look at this update badge task. They always inherit from iBackground task. You have to add that. And the one property, the one component of that interface is this run method. You know, and this is where you put all your logic. Here's all that background work task stuff. This is your cancellation stuff. There's your get deferral, and the logic here. This is the logic of our background task. Effectively, the rest of it is just kind of adornments around the running it. As you see, this background task gets the current ticks of the date time. Uses a seed to a random. Gets the next random number between 1 and 50.
Just update a tile with a random number.
And then actually what it does is it updates a tile. So it uses the badge template type, badge update manager, and blah, 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 blah. And it also writes a toast to tell you it's done it. That's all very nice. Oh, I need to turn that on again.
It's a nice use of peek view right there.
Thank you, yes. That's peek view, yes. Yeah, so let's just run this. Now, actually, the first time the UI of the app is irrelevant to this, but actually it doesn't even run because we've got an exception of type system.exception, class not registered, which is not a very particularly clear thing.
No.
Actually, what this means, so what we've broken on here is the logic that's trying to register in the foreground app that's trying to register our background task. And actually we've got a class in this called a background helper, and it's got a register method on it, and it's worth just having a look at that. Let's go to the definition. Here's our background helper. So this is all the logic is this is a reusable utility class for registering background tasks. So it does all those necessary steps that we were talking about.
Okay,
so
yeah.
first of all, it requests the access, and if we are allowed, then we break out, switch allowed, break out. Otherwise, we just quit, return null. So we can't actually run this background task. Then what we do is we find registration. This is looking to see if this task has already been registered. So this is the find registration method. You can get background task registration to all tasks. Give you a list of all of the current background tasks that are registered. We're looking for one where the name matches the one that we're trying to create. So we're looking for if it's already been registered. If it has already been registered, if we find a match, then we have to unregister it before we re-register it. You can't register it twice. No, you get an exception if you try and do that. So then now we're into a new registration where we call the background task builder. We give the name and my update badge task, the one we're just looking at, and then we also, if we've specified a trigger, we set a trigger on it, and then we register the task. Now the trigger that we've specified on this one is a system trigger type.time zone change. But the reason that's all by the by. The reason why we got that exception was because you have to register background tasks in the manifest, and that hasn't done. So it wasn't a clear error message, but if you see that class not registered, it's probably because you haven't done this.
So you've done all the C# coding bits correctly.
Yeah, but you've forgotten to do this.
this.
So you have to go into here, available declarations. You have to go to background tasks.
Yep.
And you add one of them. And at the moment it's got a red cross because you've got to specify, there's a lot of information you can specify. It's a system event.
Yeah.
And actually all you need to put in is the entry point, which is the namespace and the type of your background task, which in this case is namespace is template 10, and the actual name of that background task class was my update badge task. And we do that, the red thing goes away, and that as a minimum is all you need to do.
All right, okay. And I can have more than one of these by the looks of things.
You can have masses of these, yes, that's right. So now we'll run this and it should actually register the background task. And I could change my time zone, but then actually I'm going to show you another feature in Visual Studio instead, which is very useful.
Oh, right, okay.
Because going into settings and changing time zones is kind of tedious, yeah. There we go. Like I said, that's irrelevant, but what I am going to do is pin the tile. So the app is called Foreground app.
There you go.
I'm going to just pop that over here. It's a nice red thing. It's got the name on it, Foreground app, but there's no badge on it at the moment. And then I could change the time zone and the background task would fire. But actually what I'm going to do is, weirdly, there's a thing in Visual Studio sometimes doesn't show it up the first time. You have to do twice.
Yes, I noticed it didn't.
It was commented, it was blanked out.
Okay.
You see, this we saw yesterday with the life cycle.
We didn't see the last one,
that
right?
we didn't see. This is now, it's actually picked up the registered background task, and you can actually run it directly from here. So actually, let's see if we've got a breakpoint on it before I do that. My update badge task. So just to prove the point, so we can now run that background task, and there we are.
Oh, there we go,
You can debug it and this sort of thing. As it is, I'm just going to let it run. You saw the logic already. There we are. We've got our notification. Badge is updated to 24, and there we go. And the badge count has been updated on our tile.
Oh, very nice.
So there you go.
Yeah,
That's a
cool.
very nice, simple example of that. There you go. Like I said, we're going to look at lots more interesting examples of background tasks as the day goes on. Okay, so that was one. The time trigger, this actually goes back to that question before. The time trigger has a 15-minute floor. So if one of the ways you can actually run a background task is just say, okay, run this every so many minutes. The minimum you're allowed to do with that is 15 minutes, just so that, because people always ask this question, so we've even put it on a big blue slide. Time trigger has a 15-minute floor, okay? The maintenance trigger is interesting. So this one is when you are on AC power, so you're on charge, you've got your device plugged in, be that a phone or a laptop or whatever, or a tablet. But it's while you're plugged in, if you unplug it, it will cancel that task. But while you're plugged in, this is an opportunity for running something long running in the background.
Right, okay.
So it's an opportunity to do some sort of heavy lifting kind of work. So that's kind of an interesting one. Name clues in the name, the maintenance trigger. So there's that one. This is, just to run through that syntax. Yeah, add a trigger. You can actually put a time zone change on it. You can have one shot, which means it will only do it once, or it's repeating. And then you just have to call the set trigger method on your background task builder to set that trigger onto your background task. And that's it. And you can set more than one trigger. You can set one trigger. Only one trigger, but more than one condition. So task executions, tasks are always triggered by something.
Okay, yeah.
You've got to have a trigger.
Sense.
You've got to have a trigger, but you can optionally have one or more condition as well. So the conditions are things like user present, user not present, internet available, internet not available.
But not at the same time.
And then these other ones, I'm not going to read them all out.
Yeah.
Insert session connected, disconnected. Free network available. And work cost not high. So you can actually put these conditions actually on when you register the task, saying, okay, I only want you to run it when the system is not stressed, the work cost is not high, for example, and we've got an internet, and the user is not present, or something like that. And the way you do that is you just have a condition, you can new up a system condition, you give it a condition type, and you call add condition on your builder.
It's pretty simple.
Yeah, it is really simple. So, yeah. So what happens, the logic is the trigger will cause the thing to be ready to run, and then it will wait for all conditions to be true. So once triggered, they're kind of, if the conditions are not true initially, it doesn't mean that they won't ever run. It will just kind of wait, and if the condition flips over, then it will run. So
okay, so that's quite nice.
Yeah,
at least
you could wait for a network.
You're not going to have like random crashes or stuff like that, which is good.
Bit about resources. Right, there's a big change. So in 8.1 we had all these different resources and constraints that nobody understood. So we've simplified it now. So there is no CPU time quota anymore.
Okay.
So it's just a wall clock thing, and you get a guarantee of up to 10% of the CPU while you're running. So that's very good. The wall clock quota, yes, we have that, and you can run for 25 seconds, plus 5 seconds sort of cancellation time.
Okay.
There is a memory quota which varies by device, so it just depends. That one does depend on how meaty your machine is. But the minimum is 16 megabytes.
And is there a way to request that as an app? Can I work out what my memory quota would be, or is that not possible?
I have to come back to you on that one.
Okay.
Yeah. There is also a network quota which is variable by device. But then the good thing is every time the trigger fires, you get a new set of quota.
Okay.
So that's actually quite generous.
So you're not sharing, which is
no, because it used to be kind of slot in a slot and you'd use it and then suspend and then the next quota period would start. But actually, you just get renewed of that quota every time the trigger fires. So that's good thing. So yeah, you can run for 25 seconds. You've got 5 seconds cancellation time. Yeah. But these long-running ones, like maintenance, device use, and application trigger, these long-running can continue to run as long as resources are available. But you might get terminated without warning for these ones. So you've got to
That's the usual expectation, right?
That's right. So you won't get cancellation on those at the moment. So you just got to design these to be interruptible.
I think it's like the given rule now, isn't it? It's always just make sure that wherever you are, you always feel like you could get interrupted at any point.
So again, we talked about cancellation. Just code for this because they can be cancelled, and you're given 5 seconds to do an orderly shutdown.
Gracefully finish.
Graceful finish, yeah. Also, there's an interesting new thing as well. In background tasks don't run in your foreground app process by default.
Yeah.
Actually, it's an operating system task that is responsible for executing these things. So they run in their own
separate process.
Separate process. They share all the same storage and so you can actually access the same files and everything. And it obviously has a separate memory cap. But there's this new one now where you can actually run it in proc as well. So it runs in the same as the foreground app. So your foreground app is running in there. Background task already starts in there as well. It simplifies communication between the two, but this is going to be a specialized case. It's not going to be for everyone. And obviously it can only run when the core application is running, and if your application gets suspended, your background task goes with it.
That's true.
So it's an interesting one. But the user can put constraints on background tasks. So for example, when quiet hours, no background tasks will start and active tasks are cancelled. So that's quite stringent. Apart from voice over IP toasts and alarm toasts, of course. It would be annoying if your alarms didn't go off.
Didn't go off, yes.
And battery saver as well. The user can manage apps through the battery saver app, and they can see what apps are being, what resources they're being used, and they can choose to turn background execution off. So it reveals abusive tasks to the user. The user can actually exempt apps from the quiet hours thing as well through this. So they can say, actually I'm really happy for this to run in the background. But the user stays in charge of this, So, but key thing here is if you ask for approve, you request access async, even if you're on battery saver or quiet hours, it will still come back as approved, but then your task won't run. So
because you're approved to run it, but not currently at the moment.
Exactly. Yeah. Exactly that. Debugging. Well, we saw this. I showed you in the demo how you can trigger these things. You can go and have a look in the application log, and there's a couple of useful PowerShell commandlets you can use as well to see resource usage, for example. That's pretty useful and that sort of thing. So that was it.
Oh, wow.
That was a quick lightning introduction to background tasks. So we got much more coming up as well. So we're going to take a few minutes break now. I hope that was interesting for you. We're going to be back in 3 minutes time or so.
Yeah.
And I'll remind myself what we're doing next, which is the cloud. Okay, this is exciting. Cloud stuff. So we got a whole session all on cloud enabling your app. So see you then. Thanks.
Yep, thanks.